Welcome. I'm Ramya Devi, working as Assistant Professor in Computer Science and Engineering Department. In this video, we're going to see two concepts: inner class and inheritance. So, inner class is a class that is defined inside another class or an interface. So, the primary advantage of defining inner classes are in order to optimize the code module, in order to make the code clean and readable, and also to make the private methods of the outer class that can be accessed, so it brings a new dimension and make it closer to the real world applications. So there are four types of inner classes: nested inner class, method local inner class, static nested classes, and anonymous inner classes. The first one is nested inner class, where a inner class is defined inside the another class. So this will be acting as a member for the outer class. So if an member is defined, the member can be accessed with the help of a dot operator. So in a class contains a method which is called as show. It prints a text in a nested class method when it is called. So in the main method, we have created an object for inner class. So since inner is the member of outer, using a dot operator, we have mentioned outer dot inner. For that, we have created an object and we have called a default constructor. So with the help of an object, we are calling the show method. So the statements inside the show will be executed and we'll be getting a output called in a nested class method. So it is an example for nested inner class. So the second type of the inner class is called as method local inner class. As the name implies, the inner class will be defined inside a method. So outer is a outer class. Outer is having one method which is called as outer method. So inside outer method, the class is defined, and in turn we are creating an object for the inner class inside the method itself, and with the help of the inner class object, we are calling the inner method. So if we want to execute all these statements, we have to call the outer method. So if we want to call the outer method, we have to create an object for outer, and then with the object of outer, we have to call the outer method. That's what we have did in the main function. So for outer, we have created an object x. With the help of x, we are calling the outer method. So once this statement is executed, or the outer method, the statements inside the outer method gets executed. So it will be creating an object for inner class, and with the help of the object, we are calling the inner class method. So we'll be getting an output like inside outer method and inside inner method. So this is an example for method local inner class. And the third one is static nested classes. So static nested classes, we are going to make the inner class as static. So static inner class contains a static method. As already know, static method is a method which can be called without creating an object. That's why. So see here. So we have outer method. If we want to call the outer method, we have to create. Outer method is also declared as a static method. So without creating an object, outer method will, if we use the code outer method, these statements get executed. Instead, in order to invoke this method display, we have used outer dot inner dot display. That's it. So inner is a member of outer. That's why we have used a dot operator. Display is a static method. So static method, without using the class name, we can directly call the method. That's why outer dot inner dot display is called. So the statements inside this will be executed. So we'll be getting an output like inside inner class method. So inside that we have called the outer method. So this makes the call to the outer method. So we'll be getting an output like inside inner class method. In the next line, we'll be getting inside outer method. And the fourth type of a class is an anonymous inner class, a class without any name. So in this example, abstract is used. So abstract class, for an abstract class, as already we know, abstract class cannot be instantiated. We cannot create objects for the abstract class. Okay. So here abstract class example is defined, where it contains a display method which is declared as an abstract. So method without any definition is called as an abstract method. In the main method, we have created an object abstract. Since abstract class cannot be instantiated, we're going to create an object for this, and it makes an anonymous class is defined, and for that object we are calling the display method. So it means it is almost like an inheritance. We're going to take over the class. With that class it has been extended, and with that class object we are calling the display method. So the function definition is also given here. Java anonymous in a class, so it is a class without any name. So example is an abstract class. For this class, a class is extended without a name, and display is defined here using obj.display. We are calling the display method. So the next one is inheritance. So inheritance is an important feature in object-oriented programming. Inheritance is nothing but we are going to extract some features, inherit the properties from our classes. So class, if we're going to say we are going to inherit some properties, the properties includes data members and methods. Why? Because class contains those two things only. A class is a collection of data members and methods. So if we say properties, it refers to data members and methods. So if a class is inherited, we are going to inherit. If we say we are going to inherit some properties, we'll be inheriting some methods and some data members from one class to another. So it reduces reusability. So if a method is being inherited, I don't want to redefine the method in the derived class. I can make use of that class which is defined in the base class itself. That is the one of the advantage of inheritance. So syntax for inheriting the class is the class keyword, derived class name, the extend keywords we have to use, and the base class name. With the help of an extends keyword, we can inherit the properties from the base class. So there are 5 types of inheritance: single, multiple, multi-level, hierarchical, and hybrid. So multiple inheritance cannot be supported through classes in Java. If we want to avail the properties, if we want to define a multiple inheritance, then with the help of interfaces only, we can able to achieve multiple inheritance in Java. So this is a single inheritance where class A is a derived class. From class A, the features are derived to class B. Multi-level inheritance is nothing but it is almost like a hierarchy. Class A is a grandparent class. From grandparent, parent B is derived. From parent B, a child C is derived. Hierarchical inheritance, there will be one base class and many derived classes. So multiple inheritance, two or more base classes, and there will be one derived class. So as I said before, multiple inheritance can be supported with the help of interfaces in Java. And hybrid inheritance, as the name implies, it will be a combination of two or more inheritance. So in this example, it can be a multiple inheritance followed with a multi-level inheritance, or else this can be an hierarchical inheritance, and this forms a multiple inheritance. So single inheritance example is given here, where student is a class. It contains 3 data members: name, register number, and branch. So this is a constructor where we are getting the inputs name, branch, and register number from the user, and it is assigned to the data members. Display function, we are going to print all these details. So exam is a derived class where it is extended from student, and it also has a data members m1, m2, m3, m4 total and average, and it is having a constructor too. So usually in inheritance we'll be creating an object only for the derived class. So derived class, if you have a constructor, but in the base class we have a constructor student. When constructor will be called, a constructor will be called once an object is created. But here in inheritance, we'll be creating objects only for the derived classes, not for the base class. But we have a constructor for the base class. So in order to make the base class constructor to execute, the first line in the derived class constructor should be super. So super keyword invokes the base class constructor. So here we are going to get the details M1, M2, M3, M4 from the user, and the show marks, we'll be calculating the total average, and it is printing all the averages and marks. So see here, in the main method, we are creating an object. We have created an object for exam. S1 exam is the derived class. S1 is an object. With the S1 object, we have called both the methods, display and show marks. Display is a derived base class method. So when we inherit, this is declared as public. So this implementation will be available in a derived class also. And also it is having its own method, show marks. So that's why with the derived class object itself, it is possible for us to call both the methods, the base class method display and the derived class method show marks. So here the constructor will be called. So when a constructor is called, the first line in the constructor is super. So it invokes the super class, the base class constructor. This is how the execution will be done. So the next one is multi-level inheritance. Multi-level inheritance, the simple example is given here. There will be base class. From that base class, one class will be extended. This extended class will be acting as a base class for another class. So grandfather is a base class. Only one data member, GF name, and it is having one constructor which is used to get the grandfather name from the user. And father is extended from grandfather. Again, there is only one data member, F underscore name. So father is a constructor. In the constructor, the first line is super, which invokes the base class constructor. So we got the father name from the user. And the next one, the son is extended from father. So we have grandfather. Grandfather, from grandfather, father is extended. From father, son is extended. So for son only, we will be creating an object. Since super keyword is used in all the constructors, it will be invoking the super class constructors. So in son also we have a super keyword. So we are going to get the son's name from the user. So the display method, which will be printing all the names of grandfather, father and son. As I said before, for son we have created an object. With this object we are going to call the display method. So all the data members are declared as default. That's why we can able to access, we can able to print the details from the son itself. If it is declared as a private, it cannot be accessed. Since it is declared as default, we can able to access all these data members. Why? Because all these data members are being extended and it is available in Sun. So how the execution will happen? So for the Sun, we have created an object. So it will be invoking the constructor, Sun's constructor. So here the super keyword is here. So it will be invoking the father constructor. So again the super keyword is there. So it will be invoking the grandfather constructor. So first we will be getting the input from the user, the grandparent, grandfather's name. Then it will come here and we will be getting father's name. Then at last we will be getting son's name. In the same order it will be printed on the screen. The next one is hierarchical inheritance. Hierarchical inheritance, there will be one base class and two or more derived classes. So shape is a base class where we have an one data member area and calculate area method. So square, it is extended from shape. So it has a constructor where we are going to get the side value from the user, and the calculate area method calculates the area of the square. Likewise, the circle is a method which has been extended from shape. The circle constructor gets the value radius from the user and it calculates the area of the circle. So for what are the two derived classes? Shape is the base class. So from shape, two classes are derived. One is square. The next one is circle. So two derived classes, square and circle. For these two derived classes, we'll be creating objects. So square and circle. We have created objects for square and circle. So using those objects, we are calling the calculate area method. So the first one, it calls the calculate area of square. So it will be printing the area of the square. And the second object, with the second object, we are calling calculate area. So it will be calling the circles calculate area, and we'll be getting an output for the area of the circle. So thank you. If you have any doubts, you can ping me at ramyadevi.csc@hisa.ac.in. Thank you.